So chapter 3. So please let me know once my screen is visible.
Yeah.
Is Zoom level good enough?
थोड़ा बड़ा कर दो. Yeah, maybe a little more. Yeah, that's good.
Okay. और- ठीक है. तो हमने चैप्टर 1 में प्रॉम्प्ट चेनिंग पढ़ा था, which Manoj sir has covered, and chapter 2 was the sequential training. So sorry, chapter 2 was the routing pattern कि अगर कोई query आता है तो how do you route it. जैसे कि आपको LLM एजेंट को देना है या किसी टूल को देना है, right? So how do you decide that which tool to use or whether to send it to LLM, right? So you can use embedding based model or you can use something like rule based routing, yeah, LLM based routing. That's all, like multiple way how you want to pick which path. But that's a more of a sequential route that we take, right? Ki you have fixed everything is happening in a linear fashion. Ki you start with point A, you went to B, you went to C, you went to D, and you got your response. Chapter 3 is on the parallelization. Ki, simple, when we say parallelization, it's the simple concept is if there are tasks which are independent of each other, right? We can execute them in parallel, and if you do so, you can reduce the latency of your system or your application, right? Uh, so here they have given an example. Okay, just say agent has been designed to research a topic and summarize its findings. I'm summarize its findings, right? So search for source A, summarize source A, search for source B, summarize source B. Using these two sources, you get the final answer. Okay. Just say that you want to, you all know that probably Claude is very good at the coding, correct? But ChatGPT is much better when it comes to reasoning. Okay. So maybe you want to design a pipeline where one does the coding, another does the reasoning, and you want to compare them at the same time, or you want to get the code output from two different LLM system at the same time, compare it, and get the output. So you can execute those two operation in parallel. Okay. Uh, so yeah, that's a basic concept of how what here parallelization pattern means. Okay, so here the implementing parallelization often require frameworks that support asynchronous execution or multi-threading or multi-processing. So all the modern agentic framework, right? So when I say agentic framework, uh, not LangChain. In LangChain, it's possible to do, but it's like more of a roundabout way. But LangGraph or Google Agentic Toolkit both allow the synchronous operation. So here they have put an image where you have an input, you have a sub-agent, so you are getting output in the parallel. Manu sir or anyone can maybe you can explain even for my understanding how what like asynchronous operation or multi-threading, multi-processing is.
Yeah, so these are like you're talking about general.
Yeah, in general, yeah.
So yeah, I mean traditionally all the this RPC kind of frameworks, right? Whether you take any HTTP library or any kind of RPC call, they support both this parallel and or not parallel, synchronous and asynchronous invocations, right? So synchronous is easy. You make a call, you wait for the response, and then when the response comes, then you process that, right? But in asynchronous, there are a little more nuances. So you make the call, and then sometimes like there is a separate thread or thread pool that's waiting, that's actually listening for all the responses asynchronously. But the main thread, it moves forward, and then it, like to the programmer, it seems like they have made an asynchronous call, right? And whenever that response comes back, it's processed on a separate thread. And then there are like other nuances around how do like two threads join. Like when the response comes, it has to now join the main thread. So those are general like asynchronous processing kind of capabilities that have been there for kind of forever.
Okay.
Now they are actually kind of, I think, introducing this in LangGraph or these frameworks as well.
From the C++ side, it is like there are locks and semaphores and all these things that we can use to get multi-threads to synchronize, um, and not corrupt the data,
Yeah,
and remove the race conditions.
yeah.
So, what's the difference between multi-threading and multi-processing? Are they same thing, or there's any slight difference the way they are termed?
I think they're the same things. Like
Okay.
multi-thread, maybe like if you go at the OS level, maybe there is a difference, right? Like multi-threading is like you're running multiple threads on the same processor, but multi-processing is you are running on multiple processors. Uh, but from the application programmer's point of view, I think they're the same things.
Yeah,
Okay.
that exactly. I mean, they are the same thing for application programming point of view, but the nuance is that when you are doing a process, you are setting up a lot of things, and inside the process there can be several threads.
Yeah.
So, I mean, the setup itself is big when you are doing process multi
Oh,
processes.
okay. Got it. Yeah, I need to read more because I don't come from software engineering background, but yeah, okay, I got it. So it's all about how the system has been designed. Like it's all about architecture, right? When it comes to synchronous or asynchronous operation.
Yeah, basically you have designed your program, right?
Okay,
So
okay.
yeah.
Okay, so moving forward, so frameworks like LangChain, LangGraph, Google ADK provide mechanism for parallel execution. So in LangCell expression language, what we call LCell, you can achieve parallel execution by combining runnable object using operators. So this is a pipe operator so you use this sequential pipe operator to execute a sequential set of steps. Okay, okay. And in LangGraph, you have a graph topology. So you have a graph architecture. So in graph, it's more easier because you can define how to transition from one node to another or one node to multiple nodes, right? So LangGraph is more scalable when it comes to parallel execution, but you can also do implement same with LangChain as well. Uh, Same facility is also available in Google ADK. So yeah. Okay. So now they have given some practical application and use cases. So let's start with, we'll go one by one in each. So information gathering and research. Okay. So collecting information from multiple sources simultaneously is a classic use case. So a use case agent researching a company. So parallel tasks, one is searching news article, one is searching stock data, one is searching for social media mention, another is querying the database all at the same time. So you got lot of data at the same time at very fast speed, then sequential lookup, and you are able to get summarize it. Data processing and analysis, similar thing. You can do sentiment analysis, keyword extraction, categorization, any net entity recognition, basically identify urgent issue across batch of feedback entry. So yeah, multi API or tool interaction. You can call, just say, You are just say planning for travel, so you can check the flight price at the same time. You can search for hotel availability. You can look for the weather, event, everything in parallel rather than executing it sequential. Okay. So content generation, you can create a marketing mail. You can generate an email, draft, mail, body, everything in a one go. So yeah, I'm not getting into all of this because they pretty much mean similar thing. One thing is like interesting one is multi-modal processing that you want to process text, image, audio, video of same input at the same time. Earlier you have to do it in parallel, but this allows you to do multi-modal processing at the same go. So if there is a social media post with text and image both, you can analyze the text for the sentiment and image for the object and pass each other like have it like image as a context or text as a context, and you can different insight from different modalities very fast. Yeah. Another good use case is A/B testing, right? Because we all know that A/B testing at scale takes a lot of time, but if you do it in parallel, it can give you fast response. Now let's move on to the hands-on code example. So they have used LangChain, LCL basically to write the code. Okay. In context of LangGraph, yes, ma'am.
Yeah, so I am always confused when these chapters they say what are the use cases. I mean, this is a question to everybody. What would be a use case where you have actually the it is the multi-model multi-agent is in production, and then it goes away and does it, and it does it continuously. I mean, these are very small examples. Does anybody have any insight into this? How would a multi-agent be used?
Multi-agent, मतलब कि like they're talking about a single agent here, right? So
Yeah,
single agent.
even ये single agent भी continuous use कैसे करेंगे? सारे use cases एक kind of एक burst use cases जैसे लगते हैं. जब इसको प्रोडक्शन में करेंगे तो how are you going to use? What would be that case scenario where you are continuously giving it some input like that? Just let's say ये text image video वाला example है. What would be that scenario कि इसे प्रोडक्शन में हमने डाला और हम हर बार किसी भी ट्वीट का या सोशल मीडिया पोस्ट को 3 उसमें डिवाइड करते हैं. Would we actually do that?
Yeah, I mean, I don't know if I understand. So, like, I can give you one example how we are using it in my company. So we have this ad campaign or let's say email campaigns, right? So an email that needs to go out to let's say million users, and email also has some personalized content. Like let's say a retail company wants to send out an email and they want to send out whatever is the most recommended product for you based on your past purchase history and all that. They want to include that in that email. So whenever they process one outgoing email, there might be one task that says, go find what's the top recommended product for this customer. Another task could be summarize all that recommendation and draft an email. So some of these tasks can be in parallel, some of these would be in sequence. So and then basically that whole email, like starting from gathering content to generating email and sending email, that is the complete task for that agent.
Okay.
Then
Now I understand. Okay.
Yeah, you'll be running it in some kind of a for loop, right? For
Even for several customers, this is the agent that is running.
Yeah.
Okay, makes sense. Thank you.
Okay, so Shivam, your question was more around are there use cases where agent is running like 24 hours?
Yeah.
Okay.
Yeah, that is it is in production. It is running 24 hours. Nobody is bothering, but it has continuous input. to it. That was my question. How to,
Yeah,
what is the continuous input?
continuous input, or somebody is invoking it, right?
Yeah,
Ma'am,
yeah,
China's system is very good use case, what you said, right? It runs 24 hours, scans social media, what users are posting. It is blocking their content continuously, changing their content, right?
yeah,
So
yeah,
China's
yeah.
firewall, right? It's running kind of
Hmm.
uh, for forever, correct? So it's
Yeah,
pretty much good.
yeah. Makes sense. Makes
Uh,
sense. Yeah,
again,
security firewall is also could be this agentic system.
correct. Even social media, say Facebook want to find post with hate content, hate speech, right? So they have to
Hmm.
run it 24/7 that system at any
Hmm.
point of time.
Hmm. Hmm. Yeah.
Okay, let's move on to the code. Okay, so requirement of this code is that you have a API key, so you can use any system that you prefer. You can use Gemini, you can use OpenAI or something from like anything else, right? Uh, so you are starting. I will just. I won't go line by line, but I will try to go in as much as detail as possible. So we have OS async IO. Basically, this is what is being used to create a synchronous operation. Then you have importing LangChain OpenAI. This you are importing the chat prompt template, your output parser. Then you are creating runnable parallel and pass through, which are being used to execute the parallel operation. So you are setting your Open API key. So just FY, this code is not complete because they are not loading the API key here. So you need to define your API key in your local environment or .env file and load it using .env load in an env command, or you can hard code it while calling the API. But if you try to run this code as is, it will not work. Then you have this calling defining the model that you are using, model GPT-04 Mini, and then you are setting temperature to zero point 0.7. This is worth to mention that temperature is what defines how creative your model is. Put the temperature to zero, it will become a definitive model. It won't be a probabilistic model any longer. What a chat GPT is supposed to do, it will only fetch records what is there in just a DB or any vector database, right? So when in my company, when we design any uh, rack pipeline, just say based on HR policies and all, we keep temperature very low, even 0 or 0.05, not more than that, because we want to be very deterministic. But if you want a GPT tool which is very creative, just say you are writing a poetry or you're writing a essay, you should be using a very high temperature as much as you probably 0.9 or 1. So yeah, so this is a try and accept block here, and then you are defining three independent chains. So first chain is summarize the following topic concisely. So this is a topic. So this is a system prompt and user prompt. I hope all of you are aware of. So system prompt is what system is supposed to do, and user prompt is what you pass what is supposed to do on that particular task. So then you are so the pipe class. So I'm not sure if everyone is aware of land chain or land graph if you are not using, but land chain, when we say LCL, right? Land chain expression language, it's all about this pipe operator. What you see here is right. You have your first prompt, you are putting a pipe operator, you are chaining with second command, you are putting third operator, you are chaining with your output parser. So output parser will give you the output. So you have this prompt template where you are passing your topic. You are invoking the LLM here. You can see here LLM you defined, and then you are calling for output parser. So now this is one agent to describe one task. You can say is summarizing. Okay. Next task, similar thing. You are doing same task, but here you are saying generate the interesting question about the following topic. Okay, and third is user topic. Runnable. Sorry, third is identify 5-10 key terms from formulaic topic separated by comma. So for the same topic, you are doing three things: summarizing, which we did here. Then you are generating three interesting questions, and then you are identifying key trends or whatever. Okay. Now you have three. Then you are building a parallel for synthetic chain. Okay. So what you are going to achieve is map chain. You are by defining summarize chain. You have question chain and term chain, and your topic is what you are going to pass the original topic, your user input here. Okay. Okay,
So
so
from
yeah, you
token,
are designing the prompt here, so which will combine all the output. So this is so you got the summary from the first, we got the related questions from the second agent, key terms from the third agent, and you have user and what original topic you pass. Yes, sir.
so from token consumption point of view, right? Was because nowadays uh, the execution of LLM is actually measured from how much tokens is being consumed in invoking that LLM service, right? So as we are processing the same text and getting different types of outputs, like in one execution we are getting summary, in another we are getting some questions, and then key terms, then some topic, right? So is it feasible or advisable to pass the same input for n number of different tasks so that we can execute them fast? So is
See,
there any is being done where we can say ki, can I create a single prompt which can do all these things, or is it advisable to split into four different parallel prompts? Because right now we are studying this parallel the design pattern, right?
uh,
I think you forgot chapter one. चैप्टर वन में यही डिस्कस किया था ना कि हाउ डू यू ब्रेक
Ah,
one complex prompt into smaller tasks and what are the pros and cons. Yeah, like what you're saying, right? That one big prompt might have less number of tokens, so that is one benefit. But if you break it down, then you improve the accuracy, quality, and you also get more control. Like after every step, you can do verification.
लेकिन जो आप इनपुट पास कर रहे हो उससे भी टोकन कंज्यूम हो रहे हैं ना, कि वो
बिल्कुल
मतलब
हाँ
एग्जिस्टिंग को यूज करता है.
हाँ बिल्कुल नहीं वो टोकन यूज हो रहे हैं. एवरी कॉल इज लाइक if you have two tasks, then and you are feeding like one output from one to as an input to other, so you are consuming both output token input token.
Yeah, so I just wanted to say this, that tokens are becoming cheaper, and this is a futuristic design where you know that tokens are becoming cheaper, so you can actually parallelize stuff.
Yeah.
okay. Yeah. So yeah. Running like if you can pass input to one model and ask it to do everything, obviously it will be cheaper from an inference perspective, but output will not be great. So from a performance perspective, like Manoj sir said, you should always have a specialized agent which are supposed to do a very specific task, not multiple tasks. Okay. Okay. So moving on from this,
तो
so
इसमें एक कोड में एक क्वेश्चन है. तो दिस run parallel, right? Whatever was, if you go a little bit scroll up, yeah, this one, runnable parallel. So this is taking these three chains, running them in parallel, and then but still this one is still a blocking call, right? Like you will not move to the next statement till all the three chains are executed.
right, sir. Basically, this is what is being executed in parallel, not nothing else. This is
Yeah, yeah.
only being executed in parallel. And actually, नीचे एक comment है जो आप बोल रहे थे कि this is not even actually a parallel operation. I will come to that. So, ठीक है. So now after doing this part, you are creating a full parallel chain, map chain. I will go up. I will just show what is map chain. Map chain is your parallel operation. Synthetic prompt. This is a prompt. Okay, you ran the parallel operation. You got your result. LLM call and output. Now you are defining a function to execute all the tasks. Okay. So your argument is topic. Okay. If not LLM, this is again you are checking if LLM is not defined. Else you are try block where you are revoking full parallel chain invoke. So you are invoking this uh, command and you are passing the topic. Okay. So when you invoke this, okay. So this is your function, and then you have main block where you are using async IO to run that function. So when you call this function and you pass the topic, it will first check for whether your LLM is set well. If so, it will move here and then it will call this. If you, when you call map chain will come here. It will execute these three along with topic. Synthetic prompt will get the output and then you get the output here. Now, provided Python code implements a LangChain application designed for processing a given topic efficiently by leveraging parallel execution. Note that async IO provides concurrency, not parallelism. So it's achieved this on a single thread by using an event loop that intelligently switches between tasks when one is ideal. I think this is what Manoj sir was mentioning, that if some task is ideal, you call the next thing while you are waiting for the response from the network for the first task. Right? So this creates the effect of multiple tasks progressing at once, but the code itself is still being executed by one thread constrained by Python's global interpreter law. So yeah, yes, ma'am.
Yeah, so this GIL has been removed now in the future versions of Python. There is a threading module that has come in. So maybe the lang chain is not the ideal place to be, looking.
Ma'am, what's the like? So concurrency I understood is here is the concurrency is more like when you are waiting for a response from the network, you can call the next like whatever service is waiting to be executed, right? But what's the alternative to concurrency? Like how?
So concurrency is where you have actually, those are independent modules, and you have laid them out in such a way that now they can be executed, and they are not dependent on each other. That is how I understand concurrency. That they are not dependent on each other. So whichever they can, out of turn, they can be executed depending on, whichever there is a free thing on the event loop, whichever it sees is free, it can just use that concurrent process.
Okay, okay. So and what is this global interpreter lock, ma'am?
A global interpreter lock is actually for the safety in Python, and Python is not close to Metal language. So usually, always people use C or C++ when they are trying to code close to Metal. So, but Python is all of these frameworks are based on Python. So that is an important language, but it was constrained with this GIL lock where actually there was just a single thread, and you could do an async IO. Just meant that whenever the event loop is free, you hop another process on it, another concurrent thing can be processed, but it was always sequential kind of. Now when you use multi-threading, that's a real where it is running independently, and four threads or multiple threads are running independently. That's when the GIL is taken off in the future versions. I think 3.1, more than that. I don't remember the version.
Because I'm using 3.13 right now, but I don't think it is there. But
Yeah. I what I remember was in the future versions, and they are phasing. They're not completely removing GIL. Some catches are there.
got got it, ma'am. Okay. So yeah, again, they're just explaining the code block again. So if you want, I can just go through that quickly. So code begins by importing essential module from LangChain and all the components. You initialize the chat OpenAI instance. using a particular model. You have try except block where you check for the robustness of model initialization. Then you are defining the three independent chain, each designed to perform a distinct task. Then I will runnable parallel block is then constructed to bundle these three chains, allowing them to execute simultaneously. Okay. This parallel runnable also includes a runnable pass-through to ensure that original topic is available for subsequent step. Separate chat from template defined for final synthesis step where we are combining all the output basically. Okay. Uh,
तुमको एक चीज बताओ, ये जो लैंग चेन लैंग ग्राफ है, डू दे प्रोवाइड दैट फंक्शनैलिटी और you need to actually do this asynchronous processing using Python yourself? अभी जैसे
and
जो कोड दिखा था हमने, like they're using this async IO, right?
uh,
So that is like that has nothing to do with lang chain lang graph, right?
so LangChain you can say still kind of doing Jugaad, but because LangGraph has a graph architecture,
Mhm.
right? It has by architecture it enables you to do the parallel execution. So
Mhm.
framework itself has that even Google ADK, right?
Okay,
Has that it will allow you the parallel execution.
but lang chain does not, right? Lang chain is
No.
just executing one sequential process. But using Python, you can actually run multiple of
Yeah.
these lang chain
Yeah.
lang chains basically in parallel.
Correct. Basically, you use a async IO to
Async
that
IO.
feature to do it in parallel here in this one.
तो अगर जैसे कुछ इस तरह करना हो कि like I sprint 3 parallel tasks and as soon as any one of them returns,
Correct.
I want to actually process the next statement. So I can do that like using Python's capabilities, async IO's capability, not
Correct. Correct.
LangChain doesn't provide anything
Yeah. Yeah.
for
Correct.
that. Okay.
तो एक्चुअली मुझे लगता है जैसे रोबस्टनेस के लिए इट इज बेटर टू नॉट गो डायरेक्टली टू द लैंग्वेज कॉन्स्ट्रक्ट्स। तो ये जो एडीके है गूगल का या फिर जो फ्रेमवर्क्स हैं, दे आर एक्चुअली इंसुलेटिंग यू फ्रॉम दोज स्टफ, एंड दैट्स
Yeah.
व्हाई वी शुड ऑलवेज राइट एजेंट्स because they are robust and they can catch the errors, not write on the base language.
Yeah. But LangChain doesn't provide that.
Yeah, LangChain doesn't provide. Yeah.
Yeah. Okay.
Okay. Now next code is using Google ADK. Very similar. Okay. But I will quickly go through. I don't remember what exactly. Yeah, I remember. Okay. So they have researchers, set of researcher. One is researching on renewable energy. You are an AI agent specializing in energy. Research the latest advancement in renewable energy sources. Use Google search tool provided. So if you see here, you are providing the instruction. So this is agent like agent call, right? You are defining an agent. So this is much easier to use when compared to LangChain or LangGraph. If you want to just learn something from your purpose, I will recommend ADK over LangChain or LangGraph because it's more intuitive, more human readable. So you have it's a simple act. What's the name of your researcher? What's the model you want to use? What's the instruction you want to give? What's the description of that agent? What's the tool you want to pass to it? It's you are passing Google search. And what's your output? So rather than defining it in multiple steps, Google ADK is like more easier way to define things. You have a second researcher which is specializing in transportation. So the Google search tool provided and summarize your key findings. So it's on the research electric vessel technology. Third researcher is on carbon capture from your your company or your industry. Just say you're in transportation or automation, whatever. How much carbon emission is there from your company and how you are capturing the carbon? Okay. So we have three agents. Okay. Okay. Now you are going to create the parallel agent now here. Parallel research agent, name you are saying parallel web research, sub agent, first agent, second agent, third agent. What's the description? So you see, like it's a very easy to intuitive when compared to previous code to understand. You define three agents, then you creating a what we call orchestration agent. You have orchestration agent which will execute these three in parallel. Okay, so similar to parallel agent, you also have sequential agent actually. If you go look at ADK, now define the merger agent after the parallel agent, right? Okay, so once you get the output, what you want to do, right? Okay, so you are using a Gemini model instruction. You are an AI assistant responsible for combining the research findings. So whatever you got output from the three parallel agent, you need to combine them, right? Okay. See, this is very important part. Your entire response must be grounded exclusively on the information provided in input summaries below. Do not add any external knowledge, facts, or detail present in these specific summaries. Okay. So there's a I think we have discussed it earlier, but in if you go to interview, right, multiple time they are what's the concept of grounding. Ground is simply you rely on the information that you have got from just your rack pipeline, right? You have a vector database. You want to exclusively rely on that. You do not want agent to use anything available on web or from its memory. You do not want to invent anything. Okay. The very good example is if your rack database says that apple's color is blue, it should tell you apple color is blue. It should not, even though by its reasoning, it knows that apple is always red, but it should tell you apple is blue because that's what it is getting from its a vector what you have how you have designed or trained the system. So that's a concept of grounding. Okay. So you got the three input summary. Now you are designing the output format here. So you have like all these are comments. I'm not getting into this. I don't know where the code block. Okay, yeah. Okay, finally there's a code block. So you have a sequential pipeline. Okay, so you are first running the parallel research agent and then merger agent. So first research, then merger. Okay, then root agent. You are designing the calling the sequential agent. So this is I think very straightforward flow when what you saw when compared to uh, um, LangChain, right? And you so we are not using any async capability here. You are not calling async IO or anything. So there's a inherent capability provided by Google itself, like ADK itself here to execute task in parallel in this case. Okay, all right. So this covers this chapter pretty much. So what we discussed, like many agentic workflow involve multiple subtasks that must be completed to achieve a final goal. So sequential, it takes a lot of time. You don't want latency. Then it becomes a bottleneck if if you are doing external I operation and calling different API or querying multiple databases. Uh, and then why? Basically, we all know why parallelization is good and rule of thumb. I think this is all we know. Okay. So, yep. All right. This is on chapter 3. We have how many? 18 more minutes. So,
Yeah,
any
chapter 4
question?
is small. We can just quickly cover that.
Yeah. I covered, I went through chapter 4, like, if no one is waiting for that, so I prepared for chapter 4. So, yeah. Okay. So reflection pattern, right? Okay. Reflection pattern is simply कि लोग कि बोलने के पहले सोचने वाला काम कि when you speak something first think about it and then speak, right, to know whether what you are doing is saying or doing is right or not. Okay. So reflection pattern involves the agent evaluating its own work output or internal state using an evaluation to improve its performance or refine its response. Okay, it's a form of self-correction or self-improvement, allowing the agent to iteratively define its output or adjust its approach based on feedback. Internal critique or comparison against desired criteria. Okay, reflection can occasionally be facilitated by separate agent whose specific role is to analyze the output of initial agent. Okay. Unlike a simple sequential chain where output is passed directly to the next step or routing which chooses a path, reflection introduces a feedback loop. The agent doesn't just produce an output, it examines that output, identifies the potential issues and areas for the improvement, and uses those insights to generate a better version. Okay, so it's like not just single pipeline. You can critique it, you can put a provider feedback, it will again think about it till it able to decide if the response is good enough and give you the output. It's a iterative process. It's optional, but it should be iterative. Okay. This answers Deepak sir's questions also. Key and highly effective implementation of reflection patterns separate the process into two distinct logical roles: a producer and critic. Okay, it's called generator critic and producer reviewer model. While a single agent can perform self-reflection, so when you pass the input, you can also ask it to do the self-reflection. Using two specialized agents often yields more robust and unbiased result. So you have a producer agent which is generating the output. You have a critic agent which is thinking about it. Okay, it is a given a different set of instruction, often a distinct persona. Okay, you are a senior software engineer. You are a meticulous fact checker. Well, analyze this or check this code from that perspective or whatever. Right. Okay. So this separation of concern is powerful because it prevents a cognitive bias and isn't reviewing its own work. Okay, you don't want an agent to review so much. The critic agent approaches the output with a fresh perspective. It doesn't have that entire context, right? It just get the code block and problem statement and it is evaluating that, right? So it doesn't have that bias in its memory, you can say. So provided LangChain and ADK code example both implement this two agent model. So yeah, okay.
Yeah, I think for AI safety, also this separation of concerns is a better model. And always, I feel two different companies' models should be used in this when we are making a producer and critic kind of agent.
Right, ma'am. Yeah. So, yeah. Okay. So, reflection patterns crucial for building agent that can produce high quality output and blah blah blah. So, same for same thing again. Uh, so, in number of practical cases, reflection might act as a corrective engine, using monitoring feedback to analyze deviation and adjust its strategy. Okay. So, yeah. Okay. Effectiveness of reflection patterns significantly enhanced when LLM keeps a memory of the conversation. This conversation history provided crucial context for the evaluation phase, allowing the agent to access its output not just in isolation, again the backdrop of previous interaction, user feedback, and evaluating goals. It enables agent to learn from the past critic and avoid repeating error. So what it means is agent gave multiple feedback. Then first producer agent corrected it, correct? So now next time producer agent is working, it already knows what to produce, what exactly the evaluator agent is expecting here. Okay. Okay. Now let's go to practical agent and use cases. Just say writing a blog post, it's like generating a draft, critiquing its flow, tone and clarity, again rewriting, again critiquing, code generation and debugging, complex problem solving, propose a step, if evaluate if it leads closer to a solution or introduces a contradiction. Yeah, summarization, planning and strategy, conversational agent. So one thing I don't know why they use LangChain everywhere. Yeah, they could use LangGraph, but okay, anyway. So you need to install LangChain packages. So this is what I was telling, right? You need to save your API key in the environment.env file, and then you need to call this method to load that variable. Otherwise, your code will not work. You are defining a reflection loop here. Okay. So what reflection loop is in the new task is to create a Python function name, calculate factorial. So you are asking it to create a factorial function, accept a single integer, calculate the factorial, include a clear drop string, handle the edge cases, handle invalid input. Okay. Now you are creating a reflection loop. You try 3 times overall. Okay. So you have a message history where you have a task prompt. Okay. So yeah, you are running in loop this part, and you have a reflect stage here, and this is where your reflector prompt is. You are a senior software engineer and expert in Python. Your role is to perform a meticulous code review. You have a reflector prompt here. Okay. So critic response, you pass the reflector prompt to critic response, and then you got the content. Okay. If code is perfect in critic, okay, you are breaking the loop. Okay.
Yeah, so I think one extension to this pattern would be that you might have multiple evaluators, right? There are like small language models and large language models, and then some API calls are cheap, some API calls are expensive. So maybe you first give the task to a cheaper call, a
Hmm.
cheaper evaluator, right?
Hmm.
And then it will give you at least the first level of feedback. You incorporate that, then you go to the more sophisticated model, right? Instead, like this time in this code, they are going asking 3 times, right? Up to 3 times. So those could be like progressively to better and better model to save cost.
Okay. Yes, sir. Like, yeah, we can do we can add multiple evaluator, or we can evaluate in from different contexts also. Yeah. So, hmm. So maybe I just overlooked, right? So you are saying that if I equal to 0, you are trying 3 times, right? Here, max iteration you are defining as 3.
Yeah.
So you are invoking the LLM on the message issue. What is your message? Your message is what you say ki generate a factorial function. Okay. Else, if I is equal to 1 or something, you are saying that message history dot append content, please define the queues using the critic provided. Now you are calling the LLM invoking the message history. Now your message history has 2 things. One is your task prompt, which was added to your message history if you see here already. Second thing, when we invoke the reflect stage, right? Okay, you are going to add it. You will be adding it to your human message. See, message.history append critic of the previous code. So when you after step 0, whenever you are executing it, you are passing both task prompt and critic prompt so that it can generate a better code. Okay. Now, if critic prompt is perfect, you are saying that no further critic found, a code is satisfactory. I think we will need what you say prompt engineering here so that it only generates something like code is perfect or something. So you can stop, break the loop, and yeah, so it execute your entire workflow. So this covers up this part, and then you have
So
ADK example. I have not gone through it yet, so but things straightforward again. You have a draft writer, you have a generator. Uh, yeah, yes, sir. Go ahead.
so matlab, is it something that here with this with with the help of generation and feedback, are we trying to refine our prompt?
You are not refining the prompt, but you can say it's an original prompt plus additional feedback.
The same thing, right? Means we are adding some additional information to the prompt, using which now we are expecting that our our output should be more, uh,
Right.
more is better, right?
There are two things, sir. One is query rewriting, correct? Your prompt was not good enough. So you modified your prompt to get a better response.
Hmm.
Okay. So it's not doing query rewriting, but it is passing more information.
Nee, means so how can we ensure that the next level of output would be better than the previous one based on this reflection design pattern?
So just think from a human perspective. Sir, just say you are solving a math problem. Okay. Uh, you solved a differential equation, but you made mistake somewhere. Okay. Your teacher came and pointed out at this step you made a mistake. Okay.
Nee, if
Now
it is
you
a
know the
mistake, then my first prompt is not correct, right? If it is a mistake, then my first prompt was not correct.
so now first generation is not correct, but now you know where did you make the mistake, right, sir? So you are aware that when you generate next time, you are not supposed to repeat those mistakes or why that mistake happened. You can reflect on it and produce a better response.
Nee, I want to just understand, means is it actually uh, means correcting the mistake of LLM or for the prompt? Means LLM is executing whatever is mentioned in the prompt, right?
Yeah, it's a response mistake. We are evaluating response. So response was wrong. Reflector reflected on it. Okay, and give the feedback.
And that feedback is again appended into the prompt, and now we are expecting a new response.
Right, sir. Correct.
सो दीपक चेन ऑफ थॉट जो पहले हम लोग वो हम लोगों ने उस पे करा है, चेन ऑफ थॉट इज आल्सो समथिंग लाइक दैट ना, वो काइंड ऑफ अपेंड ही कर रहा है
नहीं नहीं, चेन
प्रॉम्प्ट
ऑफ
में।
थॉट है कि आप ये डिफाइन करते हो कि पहले मैं ये करूंगा, फिर ये करूंगा, फिर ये करूंगा, ये करूंगा, ऐसा है, मतलब स्टेप बाय स्टेप चल रहा है। यहाँ पे क्या है कि मैं एक ही रिस्पॉन्स को इवॉल्यूट कर रहा हूँ कि वेदर दैट रिस्पॉन्स मीट माई जो भी स्टैंडर्ड को मैं आउटपुट चाहता हूँ। अगर नहीं है तो मैं इसी को रिफाइन करता रहूंगा, देन आई कैन मूव टू द नेक्स्ट स्टेप।
ओके ओके, या यू आर राइट।
Okay. So again, you are Gujar, like this ADK. If you see right, you are defined subdivision generator and reviewer. Correct. So you just call it and it will execute in sequence. So, yeah. So this covers chapter 3 and 4. Both we are almost on the time. So yeah. Any, so what's chapter 5? I don't remember what is chapter 5, but yeah. Some volunteer for the next chapter.
So, Ankur, I wanted to point out this at a glance last paragraph that they gave in the chapter is quite good actually. And in the very end, this at a glance, what and why. No, you have already skipped it. ऊपर चला गया, पीछे चला, ये वाला वो काइंड ऑफ एक वो समरी होती है ना कि क्यों कर रहे हैं, और रूल ऑफ थंब, ये रूल ऑफ थंब इज इम्पोर्टेंट कि ये इस डिजाइन पैटर्न को कब लगाएं, कब यूज कर सकते हैं।
यस।
Okay. All right. Yeah, this covers everything. Any questions or we can discuss something.
हाँ, तो नेक्स्ट वाले 2 चैप्टर्स को कौन उठा रहा है?
दीपक
Tools and planning. सही है।
Abhishek sir.
तो मैं क्या अभी से डिक्लेयर कि मैं अगले हफ्ते छुट्टी पे हूँ?
I can pick up one chapter 5, then we'll see.
Chapter 5, हाँ, tools is good, yeah.
हाँ, वो
Planning
काफी
is
बड़ा भी है।
हाँ, 20 पेज का है तो it might take time also. और प्लानिंग कौन उठाना चाहता है अपार्ट फ्रॉम मनोज जी? खुश हो गए मनोज?
I'm the backup presenter for
आप
everything.
उठाएंगे? चैप्टर नंबर 6
मतलब
planning.
मैं पिक कर लूंगा, मैं
I
पढ़
I
लूंगा
I have
मतलब।
given one name, one for one chapter. I have also given a name. I updated the sheet as well.
Rakesh, you are very quiet.
अच्छा, मैं आई हैव नो इंटरेक्टेड विद राकेश सर। राकेश सर मैं
राकेश सर प्रकट हुई है।
बोलिए।
अरे फोटो दिखा दो भाई, महाराज फोटो दिखाओ अपनी।
अभी देखो खाना पीना खा लेंगे, उसका दिखाएंगे फोटो आपको।
खाना हम तो ना खा लेंगे यार वहाँ पे आके।
नहीं आज
खाना
का
भी
थोड़ा,
खा लो,
आज का
क्या कर रहे
चैप्टर
हो?
थोड़ा सा जैसे मनोज यार एक चीज बताओ, थोड़ा सा समझ में आया ये सब पाइथन। तो ये दीपक आप थोड़ा एक अलग से, आप बीच में क्लास लेने वाले थे, आपने ली नहीं
आप लोग
कि
आए नहीं,
कोड
नहीं,
कोड कोड में कैसे इंटीग्रेट करना है इस पे।
और हाँ देयर आर मल्टीपल वेज आप इसको फास्ट एपीआई में रखो। लेकिन हाँ एक चीज आज बहुत अच्छा मतलब शिवाजी ने रिसर्च किया कि पाइथन एक्चुअली मल्टी थ्रेडेड लैंग्वेज है ही नहीं।
नहीं मुझे एक चीज बताओ, आज जो समझ में आया जिसका एक सिंपल एग्जांपल ये था, एक मिनट रुक कि जो मेरे को समझ में आया कि एक एग्जांपल जैसे कि एक मेरा ऑपरेटिंग सिस्टम चल रहा है, लिनक्स चल रहा है, राइट, और मेरे पास एक ही प्रोसेसर है, हार्डवेयर प्रोसेसर एक ही है, ठीक है, वो बड़े अच्छे से यहाँ पे समझ में आया। और दूसरा एग्जांपल क्या है, मेरे पास 4 प्रोसेस है, हार्डवेयर प्रोसेसर्स ही 4 हैं, तो जो ऑपरेटिंग सिस्टम है वो चारों को पैरेललाइज कर देगा, राइट। बट यहाँ पे पाइथन